Okay, this video is to work through the big factoring problem from section 1.4. So this is section 1.4, and this is one of those you've probably seen it in the homework so far. We're looking at trying to factor out something that is intimidating for most students when they first see it. But the key thing to notice here is that notice every single term is connected by times until you get to right here and you see that we have a plus. What this means is that essentially we have two big terms, all of this multiplied together and then plus all of this multiplied together. We want to try to find a GCF. That's our goal. If we can find a GCF, we might be able to simplify this down and make it look less intimidating without distributing all of this out and making our lives miserable. So the first thing I would say to start with is on this first piece right here, try to find any monomials. Monomials can be multiplied together to at least make this a little bit cleaner. So 2 times 2x would be 4x. Bring down everything else. So I have a 6x minus 5 to the third and an x squared plus 4. Then go to my second piece over here. So I'm going to do this one in blue. I see a monomial and another monomial. Remember, monomial means one term in a parentheses when we're looking at these factors. So 3 times 6 would be positive 18. So notice I am still keeping my sign in the middle between these two terms. And then I bring everything else down. So 6x minus 5 squared, and I'm just writing them in the order that I wrote the other one in. And then x squared plus 4 to the second. Okay, once you get to this point, what we're going to be looking for is an overall GCF to write out front here. And that GCF is coming from these two separate pieces. So if you look at the monomial part, the 4 and the 18 out front are both divisible by 2. So I'm going to try to pull out a 2. They do not both have a singular x out front, so I cannot pull the x out. For the 6x minus 5s, I have 3 in the first one and 2 in the second one. So I'm going to pull out 6x minus 5 squared because that's what they have in common. This guy is to the first power, so for this matching piece, we only have 1 in common. So I'll pull out an x squared plus 4 to the first. So there, that is my GCF. In a big bracket, I'm going to ask myself what would be left in this first blob and what would be left in the second blob. So 4x divided by 2 would still be 2x. 6x minus 5 to the third, and I took out 2 of them, so I'll still have a 6x minus 5. X squared plus 4 to the first came out completely, so that one is gone. Positive 18 divided by 2 would be positive 9. Notice I still have my plus sign there. 6x minus 5 squared, I pulled both of those out. X squared plus 4 to the second, I pulled one of those out, so I still have 1. Okay, and then what you're supposed to notice at this point is that this little area can be cleaned up. Okay, because there's still this addition here, but now instead of all this stuff to multiply together, it's usually just a distributive property or FOIL, something very basic. So this GCF is still going to stay out front. You don't have to have the exponent of 1 if you don't want to. I'm going to have my bracket, and I'm going to start working this out. So 2x times 6x would be 12x squared. 2x times negative 5 would be negative 10x. Positive 9 times x squared would be positive 9x squared. Positive 9 times 4 would be positive 36. Combine any like terms inside there, so bring all of this still down. Remember, this is just the GCF that we pulled out, so it's just coming down. And I have some x squareds that I can add together. 12 plus 9 would be 21x squared, then minus 10x and plus 36. And this is now in a simplified format. Instead of having two separate terms, we've found a GCF so that we were allowed to pull it out, and then what was left was a remaining factor so that now everything is being multiplied together. Now this skill is actually really important in calculus when you learn something called the chain rule so that you can simplify some really messy looking long lines of algebra. So that is why this is an important skill, but for 136 we pretty much only use this to test whether or not you're really good at doing GCF. So that's what that's for. So let's look at another variation of this. And I need to double check this one because I believe, yes, there is a typo on this one. This was supposed to be 4x minus 5 to the third power, I believe. It just got left off. So let's look at this characterization again of this big nasty polynomial. There is a plus sign between all the different things that are being multiplied together. The big difference in this problem is that we have negative exponents, but I'm going to show you how to take care of that. So the first step, remember, is to get those monomials together. So 4 times 2 is 8. Then bring everything in that first part down. And then we have negative 2, I'm going to do this side in blue, negative 2 times 3, so that would be negative 6, so just being careful of my signs. And then I'm going to write things in the same order that they were in the first one. And then after this point, I noticed that there's still something in between the two pieces. It's the subtraction sign. So I'm going to look for a GCF to pull out front. Eight and negative 6 are both divisible by 2, so I can pull out a 2. I'm going to talk about this guy first because he's a little bit easier. 4x minus 5 to the third and 4x minus 5 to the 2. We would actually say they have 2 of those in common, so notice I'm putting that one in the second spot here. Okay, when it comes to this right here, so I'm going to highlight this in green, a negative 4 and a negative 3. When you ask what do they have in common, notice that when we had this case, the 3 and the 2, we took the smaller number. Same thing up here. When we had, let me scroll up a little bit, because this is the driving the point home of why we do this a certain way. When we had 3 and 2 here, we took out 2. When we had 1 and 2, we took out 1. We always take out the smaller because that's what they have in common. So when you ask yourself about negatives, it's a little tricky to our brains because you have to think, what is smaller, negative 4 or negative 3? Negative 4 is actually smaller. So we're going to pull out 3x plus 2 to the negative 4. Okay, so now we have to talk about what would this leave behind. So 8 divided by 2 would be 4. 3x plus 2 to the negative 4, we took the whole thing out, so that one's gone. 4x minus 5 to the third, but we only took out 2 of those, so now we have a 4x minus 5. Negative 6 divided by 2 is negative 3. We took out both of the 4x minus 5 squared, so I'm not going to worry about that, but then here's where it gets a little weird. When you say you're taking out something by a GCF, you're dividing. So essentially we're saying here is 3x plus 2 to the negative 3, and we're dividing this part we pulled out from there. So you're saying, what is this divided by this? When you divide and your bases are the same, you subtract the powers. Negative 3 minus negative 4 is actually positive 1. So my new exponent, once I pull this out, is going to be positive 1. And if you think about that on a number line, you're moving it 4 places back to the right if you were at negative 3. So it is a little strange, but you just have to think, oh, whatever I'm pulling out, I need to subtract that from this power. And then let's continue on and finish this out. So we need to distribute all of that, and then we'll have to talk about this negative exponent that we have out front. So this would be 16x minus 20 minus 9x minus 6. And that, I'm going to go ahead and simplify this right here. This would be 7x minus 26, so that's that parentheses. Now, when you have a negative exponent, you cannot leave that on the top or in its location. So since it's on the top, we have to move it to the bottom. So on top, I'm going to have my 2, my 4x minus 5, my 7x minus 26, and on the bottom, we'll have our 3x plus 2 to the 4th power. Now, it's a positive 4 because we took care of that movement. Now, I know that if you look at this on the videos in WebAssign or if you look at it in the textbook, they go about this one a completely different way. They turn these into fractions first by moving the negatives to the bottom, and then they get a common denominator. I think that actually is messier. If you just understand how to pull these powers out, it actually works a little bit easier. So that is the big factoring problem, and hopefully that will help you finish up that homework.